Alright, so we've now looked at all the different integration techniques to solve all different types of questions. So we're going to be looking at how to find the area under the graph in this video. We know that to find the area under the graph, well, we just have to integrate the equation from a certain a to b limit, and that will give us the area under the graph. But now we're going to be looking at more difficult questions when graphs overlap and when graphs cross the x-axis. So important things to note when you're first doing this, you need to find the coordinates at which if the graph crosses the x-axis. And also you need to find if the graph changes positions. So we're going to look at when it crosses the x-axis first. So if you see this question here, we're trying to find the area R1 and R2. Importantly, R1 is above the x-axis, R2 is below the x-axis. So in this case, we actually have to split it up into two different areas. We can't find the total area in one equation. So as we said, we need to find the coordinates at which it crosses the x-axis. So the equation is 3 cos x times the root of sine x plus 1. And we need to find where it crosses the x-axis, that's when y is 0. So that means cos x is 0, so x is going to be when we have minus pi over 2, pi over 2, and 3 pi over 2. So these are going to be your a, b, c coordinates. Now this is important because as we said, we can't find R1 and R2 together, we have to split it up. So we're going to integrate the equation of the graph, which is 3 cos x root sine x plus 1. Now we put the certain limits in. So for R1, it's the limits from a to b, right? So it's minus pi over 2 to pi over 2. So this will give me the equation or the area of R1. For R2, it's the same integral, so we still integrate the same graph. However, all we need to do now is just change up the limits. So now the limits are from b to c, right? So it's going to be from pi over 2 to 3 pi over 2. Once we've identified what we need to integrate and the certain limits, then it's just a matter of integrating. So it's a bit more difficult because now these equations are going to have to test your knowledge on all the integration techniques. So in this case, we're going to have to use integration by substitution. So as we said, for substitution, we need to set u equal to something, right? So we let u equal to something. However, we let u equal to normally the more difficult part of the equation. In this case, it's going to be the sine x plus 1. And because it's rooted, I'm going to say u squared is equal to that. Differentiating that, I'll get 2u du by dx. Just by implicit differentiation will give me cos x. So therefore, dx will give me 2u over cos x du, which I can replace into the equation. So we get 3 cos x times the root of sine x plus 1 multiplied by dx, which is 2u over cos x du. As you can see now, the cos x's cancel out, okay? And we just need to now replace the rest. So this is going to be 6u. The root of sine x plus 1 is just the root of u squared, which is u, right? So times u du. So this is the equation we're going to be integrating. However, now we can't forget about the limits because even though we found the limits of where it crosses, these are the limits for the x, or if it's in terms of x. This equation, this integral now is in terms of u, so we need to change up the limits as well. So for the limit of a is when x is equal to minus pi over 2. So therefore u squared is equal to sine minus pi over 2 plus 1, which will give me 0. For b, x is pi over 2, so u squared is equal to sine pi over 2 plus 1, which is 2, so therefore u is equal to root 2. I'm just going to find it for c as well because we're going to need it later. X is 3 pi over 2, u squared is equal to sine 3 pi over 2 plus 1, which is also equal to 0. So now we find the limits, we can now go about finding the areas. So for R1 is integrating 6u squared du from a to b, right? So from 0 to root 2. So this will give me 6u cubed over 3, which is the same thing as 2u cubed from 0 to root 2. Plugging it in will give me 2u to the power 3 over 2, which is the same thing as 2 times 2 to the 3 over 2, which is the same thing as 2 to the power 5 over 2. Right, that's the area of R1. R2 now, it's just the same thing, same integrating equation, 6u squared du, but now the limits are from root 2 to 0. Remember, even if one limit is smaller than the other, we still keep it in the same positions, okay? So this will give me 2u cubed root 2 to 0, which will give me actually negative 2 to the power 5 over 2. Now, important thing to note is we get a negative answer, which it doesn't matter if we do get a negative answer. The reason why is because it's below the graph, right? Anything below the graph, the areas below the graph, you automatically get a negative value. But because area is a positive value, you have to change it to the positive value. That's the important thing that you have to remember, okay? So therefore, R2 area will be equal to 2 to the power 5 over 2. So the total area will be R1 plus R2, like this, which is equal to 2 times 2 to the 5 over 2, which is 2 to the 7 over 2, like so. So the final integrating part is not the important part. It's important to understand, yes, we have to split it up if it crosses the x-axis, and we find the coordinates at which it does cross, and make sure you split up according to the right coordinate. Alright, so in the beginning I said there's two things you need to be aware of. You need to be aware of when it crosses the x-axis, and you also need to be aware of when the graphs flip, or when one graph is above another graph, like this equation, like this question here. You can see here we've now got two graph equations, and we need to find the area of each one. But in certain points, one graph is above the other, and the other graph is above the other in different points. So if that is the case, as you can see from A to B, you can see that the 2 cos x plus 2 graph is above the negative 2, which I'll draw in red, x plus 4 graph, okay? So to find the area of R1, what we need to do now is we do the upper graph minus the lower graph. So the upper graph is the 2 cos x plus 2, and we minus the lower graph, which is the minus 2 cos x plus 4. This way I will get the area of R1. Now R2 is flipped, because as you can see now, it flips where the 2 cos x plus 4 is above the 2 cos x plus 2. So we need to change it up now. So we have the minus 2 cos x plus 4 minus bracket 2 cos x plus 2. So when we're dealing with two graphs and we find the area in between the two graphs, make sure you have the upper graph minus the lower graph when you integrate it. And now it's just a matter of integrating. Right, we've set it up. Now we just need to find the limits, right? So we need to find where they are crossing. So we have to just find the intersection points. So we just equate them together like this. So we can say that minus 2 cos x plus 4 is equal to 2 cos x plus 2. We'll get 2 is 4 cos x. Cos x is 1 over 2, so x is pi over 3. It can also be minus pi over 3, and it can also be 5 pi over 3, because we need this 3 points as A, B, C, right? So this would be coordinate B, this would be A, and this would be C. So for area R1, the limits will be from A to B, which is negative pi over 3, to the coordinate of B, which is positive pi over 3. And for R2, it will be from B to C, so it's be positive pi over 3 to 5 pi over 3. Now this integration itself is not too difficult. It's just integrating cos and cos, which is just sine, and just plugging in the same or the limits. So there's no like substitution going on or reverse chain rule. But as we said, importantly, just recognize when one graph is above the other. If they flip, then we have to find the areas separately. Also, like the previous example, if the graph crosses the x-axis, then we also once again need to find the area separately.